Good morning everybody, and I welcome you to this tutorial. In our last tutorial we are looking at gases in the atmosphere. So in this tutorial today I want us to look at another experiment of determining the percentage composition of oxygen in the atmosphere. That is using phosphorus or combustion of phosphorus. Here we use this apparatus. As you can see, we use a bell jar. This bell jar has a bung which we use to cover. Then you invert it in a trough of water. Then you put phosphorus. You make sure it is floating on water. After setting up everything, you mark the initial volume of water inside this bell jar using a permanent marker or waterproof ink. You mark here. Then after marking, you remove the bung, use a hot metal wire, and then you ignite this phosphorus. Immediately after igniting the phosphorus, you cover. The phosphorus will be burning. As it burns, it uses up oxygen in the air that is in this space. And you will see the whole bell jar will be filled up with white smoke of phosphorus oxide. As oxygen in the air is being used up, it creates a vacuum which forces water level inside the bell jar to rise. So eventually the water level will rise again to replace the space that was occupied by oxygen. And eventually even the white smoke will disappear. Why? Because the phosphorus oxide is soluble in water, will dissolve in water. So when the water level stops rising, you mark another level using a permanent ink marker, or you can use a waterproof ink. Then after, you invert, you turn this bell jar upside down, you fill it with water up to each mark, and then you measure that water volume using a measuring cylinder. Then the change you get is going to be the change you get in volume is going to be the volume of oxygen that was used up. So here we have the steps which you can use. You put your phosphorus in an evaporating dish, you place on water, you invert a bell jar, you record the initial volume of the water in the bell jar using a waterproof pen, you ignite the phosphorus using a hot wire, you replace the bung immediately. As phosphorus burns, the white smoke fills up the jar, which eventually dissolve in water. Then finally, when the water level stops, you mark that water level, and then you get the change in volume, and then you calculate the percentage of oxygen in air by getting change in volume divided by the original volume. Then we come to combustion of elements in oxygen. Combustion will mean a chemical reaction involving burning a substance in air. Whenever you burn a substance in air, we say you are doing what we call combustion. Elements, they burn more brightly and rapidly in pure oxygen than when you burn them in air. The reason is because in the air there is only 21% of oxygen, the rest are other gases. But when you use oxygen, it's 100% pure oxygen. So the reaction will be faster and the elements are going to burn more brightly. You'll be seeing the colors more easily. So we come to examples of reactions, combustion reactions. One, we have magnesium. Magnesium burns with a bright white flame or intense white flame. to form a white powder. That white powder is what we call magnesium oxide. As you can see in this equation, our magnesium bonds with oxygen, reacts with oxygen, and it gives us magnesium oxide. Even hydrogen, all these reactions, they are exothermic, heat is given out. Even hydrogen burns with a pale blue flame, giving us water or steam. As you can see here, we have hydrogen burning with oxygen to give us water. Sulfur also burns with a blue flame to form a colorless poisonous gas, and that colorless poisonous gas is sulfur dioxide. As you can see here, sulfur reacting with oxygen to give us sulfur dioxide. So when you look at those reactions, that white magnesium oxide that is formed is slightly soluble like all other metal oxides. And because it's slightly soluble, the small part of it will dissolve in water and form an alkaline solution of magnesium hydroxide. As you can see in this equation, this is magnesium reacting with water, giving us magnesium hydroxide. Then sulfur dioxide that is formed from combustion of sulfur, for it is soluble. It's totally soluble. So it dissolves in water to form an alkaline solution. As you can see here, this we have sulfur dioxide dissolving in water, giving us sulfurous acid. So because it is soluble, it dissolves in water and forms an acidic solution of sulfurous acid. Then with hydrogen, for it just burns with a blue flame, pale blue flame, and gives us water. Then we come to oxides of metals. For oxides of metals, when we talk about a metal oxide, we mean an ionic compound containing oxide ions. When you look at the properties of oxides of metals, they are basic, meaning they can react with an acid and form a salt. They are usually insoluble in water, though some can dissolve in water and form alkaline solutions, solutions that contain OH ions. We have another type of another type of oxides, that is the non-metal oxides. These are normally covalent compounds that contain oxygen atom. For example, we have sulfur dioxide, carbon dioxide, and many others. But these oxides are normally formed by non-metals. When you look at their properties, they are usually acidic oxides, meaning they react with alkalis and form salts. They react with alkalis and form salt. They are also often soluble in water and form acidic solutions. Then we have this assignment, which I would like you to try in the next 30 minutes. Then you can submit after 30 minutes. Thank you for watching.